So good morning, good afternoon, good evening to everybody. Welcome to this edition of our STARS webinars. I'm Tony Schönenberger. I'm the co-founder and executive chairman of STARS. Today we have the great privilege and pleasure to talk to John DIENER. John, welcome. It's really great to have you on this webinar. Thank you very much for joining.
Thank you. Thank you. It's great to be here.
Actually, John is now in San Francisco. It's 1 o'clock in the morning. So again, thank you very much for joining. John is a Singapore-based entrepreneur. He's a co-founder and CEO of Vertical Oceans. We will hear more about it in a minute. John also advises and mentors startups. Formerly, John was an executive in agri-tech and aquaculture companies. And last but not least, I should mention that John is a STARS alumnus. We have approximately 30 minutes to discuss with John. First, John will give a short presentation of approximately 10 minutes. If you have any questions, please use the Q&A feature below to type in your questions. And please do it as quickly as possible because time is running out quickly. John, thank you very much again. And we are looking very much forward to your presentation. The floor is yours.
Thank you. Thank you very much. I will just share a quick presentation to give everyone a quick overview of our company. Let me just see if I can share the screen here. Is everyone able to see my screen? See the presentation?
Yeah, that's great from our side, yes.
Okay, wonderful, wonderful. So the genesis of Vertical Oceans came back in 2016 when I was the CEO of an aquaculture, nutrition, and genetics company based in Singapore. And at that time, I had visited hundreds of shrimp farms around Asia and kept seeing a similar pattern where, you know, a lot of the farms look like what you see in the bottom left corner of this image, where it's sort of cut out of mangroves, and then, you know, they're dumping effluent into the ocean and bringing even some of that water back into their farm and ending up having issues with disease because of that. And then some of the farms use antibiotics, and a lot of the feed uses wild caught fish meal and so forth. And it was very frustrating for me to see that because I love the ocean. And at the same time, I knew that aquaculture could be an efficient way of producing food. So I started thinking about how technology could be used to make it better, and started thinking about that there must be a better way to do this. And as a critical context for all of this is the fundamental belief that aquaculture is an efficient food production model, just not the way that it was done. But also that food security is important, and food security is fundamentally about availability and quality. And, you know, as we all experienced over the last 2 years, COVID has really increased the urgency around food security. And there was already a trend of decentralized food production before COVID started, and COVID has now significantly accelerated that trend. And in addition to all of that, it's just the fundamental belief that our food systems can be much more sustainable than they are, and there's a lot of progress on a number of fronts to increase the sustainability and efficiency of food production. But aquaculture traditionally was a bit of a technology lagging sector. So, you know, aquaculture was mostly invented in the 1970s and the 1980s, and some aspects have improved since then, the nutrition and genetics particularly, but other elements of the production model really were fairly backward in terms of technology. So it was a perfect food production model that was ripe for reinvention, and that's what we did. And that reinvention starts with a biocomputer. We call it the Intelligent Habitat, or IHAB for short. And it's about the size of a bus. It's a fully autonomous production module. So you see that yellow thing on the top, that's the lid that goes on top of it. So it's fully enclosed and and modular. And inside of that biocomputer, we have an aquatic ecosystem that replicates elements of what the natural ocean environment would look like. Our primary production is shrimp, but we also have a biofiltration using a filter feeding fish as well as seaweed. And by having what we call a multi-trophic ecosystem, it actually creates a more diverse microbial environment as well, which makes the system more robust and less prone to bacterial pathogens and so forth. So the water just recirculates inside of this biocomputer. What's critical to all of this is that we manage that ecosystem all the way from the microbiological level to the microprocessor. So we only feed our shrimp, and we've developed a proprietary feed that doesn't use any wild caught fish meal. We don't use any soy, so the sustainability of the ingredients is very important to us. But we've also reformatted that feed to make it more bioavailable for the shrimp. And then whatever's left over from the shrimp zone, any organic matter from the shrimp production area is filtered out by the filter feeding fish, and then the seaweed converts the nitrogen from the protein into the seaweed biomass, which we also harvest. Around that are a number of sensors that are keeping an eye on the shrimp behavior, that are looking at the water quality parameters and other characteristics of how the system is functioning. And those sensors are feeding input into a number of different algorithms that are then controlling things like how fast the pump is running, how much feed is being dispensed, and when that feed is being dispensed, so that it's constantly optimizing for ensuring that the conditions are correct, but also minimizing the inputs in terms of energy and feed and so forth. The net result of this is that we're able to grow to jumbo size shrimp in 55 days. And that compares to a standard pond aquaculture environment where it would take about twice that long. So it would take about 100 to 120 days in traditional pond aquaculture to achieve those growth rates. And the other element of it is because we're able to precisely tune the feeding, we're able to get a feed conversion ratio of 1, or actually just a little bit below 1. So it's a very efficient system. So because those IHAB modules are autonomous and they are fully self-sustaining, we can actually stack them in a vertical tower. Now, our towers won't be quite as architected as this rendering. It'll be a little bit more of a box shape, but the idea is the same. And one of the great things about that design is that it allows us to produce food at the point of consumption. So most of the shrimp is produced in Southeast and South Asia, a little bit in Central America, but most of the shrimp is consumed in North America. So that, that would be in Europe, North America, and North Asia. And with the system that we have, because it's very efficient and it has a very small land footprint, we can actually bring the production to the market. There's a lot of value in being able to do that, not only from the perspective of eliminating all of those food miles of bringing and freezing the product and bringing it to, in the case of the US, it travels about 10,000 food miles before it reaches the market here. So by producing something local and fresh, we're able to get a premium price. And that more than offsets the incremental costs of our system. The system is highly automated, so we don't need a lot of manpower to run it. And that's important because in urban environments these days, it's very difficult to find workers. It's also very energy efficient, and it doesn't seem like it would be, but we can actually produce the tropical species that we produce in the wintertime in a place like Chicago where it's very cold, because our modules are insulated and the building is insulated. So we're actually able to do all of that in a very energy efficient way. And it's on a very small land footprint. So on a land that's about 6,000 square meters, we can produce 1,000 tons a year of shrimp, which is a significant amount. So it's a really unique model. And by being able to offer same day farm to fork shrimp, customers really appreciate and love the aspect that they're getting something that just came out of the water a few hours ago. And I'll talk about a bit more about that in a moment. So in order to make all of that work, we had to really take a comprehensive systems engineering approach. And our system is a combination of bioengineering, hardware engineering, and computational engineering. And so we borrowed the systems engineering methods that they use at NASA, and we're tracking 83 technologies in our system, of which 27 of them are patentable. Where we could, we use technologies that were available off the shelf, and we've used technologies from the aerospace industry and nanotech and logistics and so forth. But there are some areas where there was nothing available, so we had to invent our own solution. One of the things that even surprised us was how unique the product is. And we sell direct to consumer in Singapore from our proof of concept facility, and the customers really love the product. And they love the fact that it's, you know, same day fresh. It's got a really good seafood taste. So the product itself is fantastic, but customers also really appreciate the sustainability aspect of it. We don't use any chemicals or antibiotics in our system, and our system doesn't produce any effluent at all. So it's something that you can feel very good about, and it tastes fantastic. Where we are now, so we were founded in 2020. We went through the accelerator IndieBio. We had a very successful seed round of funding last year, 4 million. And we've just started to scale up our technology to a larger proof of concept facility, which is right downtown in Singapore in Tanjung Pagar. And we are doing the engineering on our first commercial scale facility which we hope to start construction in 2023. So we're making pretty rapid progress. So anyway, I'll end it there, but hopefully it gives you a bit of a quick overview of who we are and what we're doing.
Great, thank you very much, John. Fantastic insights. There are obviously only advantages. You mentioned some of them, no chemicals, no antibiotics, sustainable production, quality, etc. So the question would be, what are the challenges or the disadvantages of your technology?
So the main challenge that we deal with is how you balance the nutrients that go into the system with the nutrients that are converted in that system into a harvestable biomass. And in order to get that, what we call the mass balance of those nutrients correct, is very, very challenging. Because we're able to use the technologies that we use, we're able to manage that. Pretty well, but the algorithms are really critical to doing that. So just to illustrate that, so we use, the protein. There's protein in the feed, and when protein is metabolized, it produces ammonia as a byproduct, and ammonia can be toxic for most aquatic species. So we have the seaweed that's there to absorb that ammonia and take it out of the water. And as the biomass increases, we have to add more nutrients into the water. And so we have very specific lighting recipes. We actually had to create our own underwater LED lights to grow the algae. And we have to give them a very specific lighting recipe to increase the amount of ammonia that they uptake over time. So that's just one example of some of the complexities and challenges that we have to deal with. And it's quite, it would be impossible without these algorithms.
You said, or I read somewhere, that the global market of shrimps is approximately $50 billion. Could you really replace the traditional shrimp production 100%?
Great question. We'd love it if we could. So our target is actually to replace wild caught shrimp. So most of the farm shrimp is frozen and processed before it's sent to market. So our real position in the market is to replace the fresh wild caught shrimp, which is usually only available seasonally. tends to be a little bit larger sizes and tends to be at a higher price point. So we're starting there. So that's really more at the top of the pyramid, so to speak. So if you think about that $50 billion market, about 20% of that market is in that more premium segment where you're talking about fresh or wild caught shrimp. And that's really what we're focused on. If we could even just get $1 billion of that, that would be a huge accomplishment for us. And it would only put a small dent into that. But if we can even just replace a lot of that wild caught, we would take the pressure off of natural fisheries, which is our first objective. And then later, maybe we can go after the more commodity segment.
We have a couple of questions. I would like to put forward these questions from Peter Wiedel. I just read it. Do you also follow on a trend to grow food on flat roofs, e.g. green city growing in Boston? Might this become a hype?
Yeah, we get that question a lot. We can't, like some people say, well, why don't you just put one of your IHABs in a supermarket and then, you can just take it out. The system really, there's a lot of central services that are required to support the way that the system functions. So it really has to be done in our specifically designed towers, where we've got the ability to centrally handle the IHAB units and so forth. So it doesn't really work on this kind of rooftop concept. It's a bespoke, custom engineered building with a lot of automation and robotics around it.
But vertical farming, meaning growing vegetables in towers, very similar to your concept. Is that feasible, or is that a new business area for you?
No, we don't have a plan to do vegetables or that kind of thing. Our model is to produce seafood. Right now we're focused on shrimp. We can also produce other tropical seafood species. So for example, we could grow sea bass in our system. And we do have a plan eventually to add other species to that system, but we don't have a plan to do terrestrial crops. One of the big differences between our vertical farming model and vertical farming of greens is that the energy usage is a lot lower. So to grow lettuce and that sort of thing in an indoor vertical environment requires a lot of light. And it's just hard to compete with the sun in terms of the efficiency of providing that light, and it does use a lot of energy. We don't use anywhere near that amount of energy, so it's more efficient from an energy input perspective. And some of those vertical farms are profitable, but others are struggling because the cost of the electricity is just very, very high.
There is another question from Anita Fani. Where do the shrimp fries come from? That's one of the main problems in Bangladesh, that they are taken from the sea.
Yeah, great question. So there's a number of shrimp breeding programs that are very well established around the world. And these breeding programs have domesticated the shrimp from decades ago. So these are not taken from the wild. These are genetically selected animals that are selected for growth and for robustness against disease and so forth. And they all come from biosecure, clean facilities. So yeah, we don't take anything from the wild for that. And even our seaweed is our own strain that has been taken from a facility in Japan. So we're not taking from wild stocks.
There's a question from Professor Gordana Kirans. She's professor at Shenzhen Technology University in China. What kind of waste does occur, and how do you deal with it?
Good question. So we operate as a zero discharge facility. And that's one of the other challenges that we have to deal with, because we can't discharge seawater or salt salt water, because our system is a marine system. We can't discharge that into the sewer systems of any city. And anyway, it's our goal to have a zero discharge. So we do have some residual organic matter, and we're able to the portion of that that's not filtered out by the multi-trophic ecosystem, we filter that out mechanically, and then we concentrate it. We can actually use that as a substrate to grow other things. So we can, we actually right now are using it as a substrate to grow the algae, but we can also grow other aquatic species that can then be upcycled into the feed or as nutrition for the system. So there's multiple ways that we deal with that, and we're working on determining what's the most economically productive use for that. But the idea is that everything is upcycled and stays in the system.
There's a question from Suzanne Araba-Reneve from Geneva. What is the CO2 footprint of a vertical ocean shrimp as compared to an artificial pond and a wild shrimp?
Great question. So, we've done a high level life cycle assessment, but we haven't done a complete life cycle assessment yet. Our current estimates is that we would be, from a carbon footprint perspective, we would be at about 15% of the carbon footprint of wild caught, and that we would be about 1/4 of the carbon footprint of farmed. So, our carbon footprint is quite low, and there's a number of reasons why we're able to do that. One of the big contributors to the reduction of that carbon footprint is just the fact that we're producing at market, and so the food miles is very, very small. But also because of the nature of the ingredients that we use in our feed, for example, which is another major source of the carbon footprint, we're using more sustainable ingredients. They cost more, but they're more sustainable, and therefore we're also able to reduce the carbon footprint there. So we estimate that our carbon footprint would be on par with or even slightly lower than plant-based alternatives even.
There's another question from Nico Decotins. Is animal welfare something you address? And how does it compare to wild caught or traditionally farmed shrimp harvesting?
Yeah, great question. So all of us at Vertical Oceans, I mean, we're all driven by the motivation of doing the right thing and sustainability. I mean, everything we do, even the condensate off of our air conditioner, we collect that water because that's water, and we use that. And we do think about the welfare of the animals. And so in the way that we harvest them, we actually harvest them in a way where it's much more gentle. And they're not just yanked out of the water and left to suffocate in the air and so forth. We actually put them in a chilled water environment, so it's a smoother process. And the aquatic environment that they grow in is much healthier than pond raised. So in a pond raised system, you keep adding nutrients in it, and the water gets kind of dark and quite polluted. Our water is a light green color. It's much closer to what they would be experiencing in the wild. But we also add things to the environment. So for example, when shrimp are molting, when they lose their shell periodically, they're very vulnerable, and they can't swim as easily because their shell is soft. So they like to be able to kind of hide, and so we've actually created devices in the system where they can, when they're molting, they can go and hide and wait until their shell hardens to move around. So we do think about that a lot. It's something that we have a respect for all living creatures, whether it's plants or animals or anything else, and we endeavor to try to make it as comfortable an environment as we can.
Right. Where will your industry as a whole be in 2030?
In 2030, I think the aquaculture industry in general is moving in two directions. It's moving on land, so systems like ours, inland recirculating systems, and it's moving offshore. So, the salmon farming industry is already starting to make moves to have these offshore pens and so forth. And I think that's really where the industry is going. as well as generally improving the traceability and sustainability footprint. And everyone is aware that we need to be more efficient about how we use resources, and I think the industry is really starting to embrace that now. So it's great to see that.
There's an additional question from Nico Decotins asking, any plans for expansion into Europe?
Yeah. So our idea is that we would like to have a vertical ocean in major urban centers around the world. And right now we're just evaluating our rollout plans. So we will start engineering on our first commercial scale vertical tower in the second half of this year, with the idea of constructing our first tower in 2023. That's most likely going to be in Singapore, although there's some interest in other geographies. And as soon as we're able to validate and confirm that all the technology works and we're able to work the bugs out of the system, because you always know there's going to be some surprises there, then we will start to scale it up. And our business model is designed for scaling up rapidly. And then we would start to expand into Europe and North America and North Asia. There's a lot of interest in Japan, for example. So it's I mean, we would love to have 50 vertical oceans by 2030, and we certainly will do our best to try to expand as quickly as we can.
I hope you are doing one in Switzerland, because I really love shrimps.
Yeah, we would love to do that. I like Switzerland, so yeah, we actually have interest in Hawaii, of all places. So you think Hawaii, all the seafood there is locally wild caught and so forth, but it's not. And there's some interest from the government there to have a local and sustainable food supply chain. So we actually have a project in Hawaii as well. So let's see.
There's another question by Susanna. Any competitors?
Yes, we have competitors. So in Singapore, believe it or not, and this is not by design, I think it's just sheer happenstance, Singapore is the world leader in vertical aquaculture farming. There's 2 other companies in Singapore that are working on their own vision of a vertical aquaculture system. There are 2 companies in the US that aren't really a vertical system, but it's a kind of managed or more advanced technology system that's fully recirculating. So there are a few other systems that are out there. Nobody's taken quite the extreme approach that we have in completely rethinking every aspect of it. But it's great to have competition, because it just pushes everyone to do better. And we don't, we're humble enough to know that we're not going to be the only company doing this, and we welcome the fact that there are other people who are trying to also make food production more sustainable. So we embrace that.
What other trends in food innovation do you see right now?
I think that all of the work that's going on around microbial protein production is very interesting. And the cellular agriculture gets a lot of attention these days, but the technology that's likely to probably massively change food production, particularly protein production, because that's the hardest part of the food chain to produce, coming from known organisms that are able to grow in bioreactors using yeast and things like that. I think that's going to really explode in the next couple of years, and that's going to be a game changer for the total food production system, because those proteins can be used directly in making food for humans, but they can also be used in feeding livestock or aquaculture species for human consumption. So I think that's going to be a significant impact. And some of the other areas that are interesting is in novel materials. So for example, one of the companies that I advise, a company called MycoWorks in San Francisco, they produce leather from mushrooms, and they launched a bag with Hermes recently, where the bag is made out of their mushroom leather, and that mushroom leather actually performs better than real leather in many ways. And so I think we'll start to see some interesting biomaterials that will replace extraction of or other exploitative ways of doing things. And finally, I would say that I think algae, seaweed produced in the ocean is starting to get a bit of momentum. And for me, that would be also a really fundamental game changer, not only for cleaning up the environment, but seaweed has a lot of interesting ingredients around protein and healthy oils and so forth. So, yeah.
I have a final question, John, if you allow. Time is up already. We have quite a few young business leaders looking at the webinar right now, and you also advise and mentor startups. What advice would you give to young entrepreneurs, startups?
Yeah, good question. You know, so I have experience in developing and scaling technology and working with startups before. But even despite that background, we went through this accelerator program, IndieBio, which is a pretty well-known biotech, agri-tech accelerator in San Francisco, and we benefited tremendously from that. My recommendation is that if you have a startup, go through a quality accelerator, because you learn about things that you didn't know you needed to know, and it'll really give you a great head start. You do have to give a bit of equity, so it's not free, but it's worth that trade-off. Because one of the issues that I see with a lot of early startups, and particularly people who've never done a startup before, is they tend to think that giving equity away and dilution is a bad thing. Dilution doesn't matter if you increase the value of your company. So, and those, you know, a good accelerator can really help you out tremendously. And the other bit of advice would be to just get advice from other people, because there's a lot of things that you don't know that you need to know. So.
Great. Thank you very much, John. Time is up. We have to come to an end. First, I want to thank you very much for your brilliant insights. I think we all benefited a lot from what you said, a fantastic look into the future. So thank you very much again, and I wish you and your company all the best and every success. And I very much look forward to seeing you in Singapore at the next STAR Symposium in June of this year. Thank you very much again.
Yeah, thank you.
The next webinar will be with Markus Herrmann. He will be talking on China, strategic developments for decision makers. I hope to see you there. In the meantime, thank you very much. Take care and goodbye.